All right, so to finish up these last few problems in the review packet, now we're on number 12. Find the absolute extrema of f of x on this interval. So we need to find the critical numbers, and then we're testing the endpoints and the critical numbers into f of x and just seeing what's the highest and what's the lowest. So this needs a product rule. First, times derivative of the second, which would be 2 times x plus 3, times derivative of x plus 3, which is 1. You don't have to write that, but it's a good idea in my opinion. Plus second times derivative of the first. And then we clean this up a bit. So this is really 2 times x squared times x plus 3. And over here we have plus 2x times x plus 3 squared. I would like to factor out a GCF on this because I'm setting it equal to 0 for critical numbers, so factoring is the way to go for that. So I can factor out a 2x times x plus 3 from each term. So if you do that, 2x squared over 2x leaves you with x. The x plus 3's cancel out. 2x over 2x cancel out to 1, and you're left with plus x plus 3 to the first. We don't really need the parentheses if this is just to the first power. So I have 2x times x plus 3 times 2x plus 3. So there are 3 critical numbers for this. X equals 0, -3, and -3 over 2. And remember, you don't need a number line. We're not doing first derivative test. You're just saying, what are the candidates for the extreme value theorem? What are the candidates? They are the endpoints, which I always just list right there, and then the critical numbers. So I'm not worried about going in order for these numbers. I'm just writing them down. And then we need to plug each of these into f of x. So if I put in -5, I get 25 times -2 squared, so 25 times 4. If I put in -1, I get 1 times 4 squared. 1 times 2 squared, which is 4. So that's 4. If I put in 0, I get 0. 0 times 3 squared, but that's 0. If I put in -3, I get 9 times 0 squared. That's 0. And -3 over 2, that would be 9 over 4 times, let's see, -3 over 2. So -1.5 plus 3 is +1.5, and then you square it. So you get 81 over 16. All right, so what is the absolute min and what's the absolute max? So lowest number that I see are the zeros. So they're actually, because they're both the lowest number, there are 2 absolute minimum values, 0, 0, and -3, 0. Those are the points anyway. The minimum value is just 0. And then the max is 100, and that occurs at -5, 100. All right, what about number 13? Write the equation of the tangent line at x equals 1 and use it to approximate f of 0.9. So what do we need to write a tangent line? We need a point. So they tell me that x equals 1. What does f of x equal? So when you have the input of 1, you get an output of 0.84. And what's the slope? Sorry, I'm trying to save room here. So what is the slope? That's f prime of 1. And f prime, when we input 1, we get out 0.58. So the equation for the tangent line is just y minus 0.84 equals 0.58 times x minus 1. So there's the tangent line equation. When they say use it to approximate f of 0.9, that just means plug 0.9 into this tangent line equation. So y of 0.9. Well, actually, let me write it like this. I kind of like this. F of 0.9 is about equal to y of 0.9. And that equals 0.58 times 0.9 minus 1, so -0.1, plus I would be adding this 0.84 over. And, we probably could do this without a calculator if we really had to, but it's early. Let's just do this. 0.58 times -0.1 plus 0.84, I'm getting 0.782. So f of 0.9 is about equal to 0.782. All right. And we briefly talked about this in the concavity notes. Your approximation is higher than the actual value of f of 0.9. Is the function concave up or concave down? So if they tell me that the approximation, so here's a little tangent line, whatever, is higher, that means that, again, I mentioned this in the notes, it means that, f of 0.9 is maybe sitting like right here because this is f of 1. And so that point is higher. That means that the graph has to be concave down at that point, because if it were concave up at the tangent line, then at 0.9, my value would be sitting lower than what the actual graph is. So concave down. Okay, number 14. This is our last problem. The area of a rectangle is 64 square feet. Find the dimensions that will minimize the perimeter, and use calculus, because again, you could do this by finding a vertex, algebra 2 style. Start with the number they give you. So the area of a rectangle, let's just say our rectangle is x times y. So x times y is equal to 64. And what would the perimeter of the equation be? It would be p equals 2x plus 2y, perimeter of the rectangle. And remember, once we get these two equations, you solve the number equation for one of the variables. I usually solve it for y, so that I can, so that I can sub that in to the y in the equation, that we're trying to optimize, minimize, or maximize. So I want to make this p equals 2x plus 2 times 64 over x. And I want to take the derivative of p with respect to x. So I'm going to take the derivative with respect to x of both sides of this equation. Because if we're trying to find a max or a min, we're trying to figure out where is the derivative equal to 0. So dp dx should equal 2. And then this would be minus 128 x to the negative 2, or over x squared. And with derivatives, remember, we like to get this into one fraction. So multiply 2 by x squared over x squared, so that you can put this whole thing over x squared. So the critical numbers would be, let's see, 128 over 2 is x squared equals 64, so plus or minus 8. And then you also get 0 from the denominator. And remember, we are talking about dimensions of a rectangle. So I still like to put all of these numbers, but I don't necessarily have to test all of the intervals. Like I know that x, a side length, can't be negative. So these two sections are out. So I really only care about these two intervals. And I am going to test in here because I don't know what this graph looks like easily offhand. So if I plug in 1, I get 2 minus 128 over 1. That's definitely negative. And if I plug in something like 9, I get 2 times 81 minus 128 over 9 squared, 81. So 2 times 81 is 162. That's definitely positive on top over a positive. So P, the perimeter decreases and then increases. So find the dimensions. I know that the max perimeter occurs when x equals 8 and y equals 64 divided by 8. So y also equals 8. And I should label those in feet. If I had to justify, I would say in words, because p prime changed from negative to positive. So remember to look over mean value theorem in your notes packet. Like, what was mean value theorem again? There's some practice in AP Classroom on this. So there's practice on this stuff in AP Classroom. It's optional. I'm not taking it for a grade. That's all that optional really means. But you really should do the AP Classroom problems because they practice multiple choice. Remember to practice free response. You can go back and rework the problems that were in your curve sketching packet. All right, that would be good to do. Go back and look through any of these homeworks. You don't have to redo every assignment, But you really should be looking through things or watching my videos at the very least, just to kind of run through things again.